There's a slight change to the program. In the program it said Robert, but he had some family circumstances, so he was not able to join. But instead Paul joined from Adjust, and he will give a talk about why and how they scale their environment completely on dedicated servers, and not so on bare metal and not on cloud infrastructure. And I see he's already set, so give a warm welcome to Paul.
Hey. Okay. All good. Thanks. Yeah, good morning. Good morning, everybody. You already heard the bad news that, hey, sorry, that is not supposed to. Sorry. There you go. Okay. You already heard the bad news. I'm not Robert. I'm Paul. I'm the CTO and co-founder of Adjust, so I hope I can give you the same kind of presentation that Robert would have given. The focus is a little bit technical than the previous talk. It focuses on mainly the commercial reasons why Adjust is actually not using any cloud-based services in its production system. So, just let me, looks ugly there. Come on. So, Jesus, come on. There you go. Okay, so. First of all, what's Adjust? Like, I reckon very few of you have heard of us. Some of you are actually our clients, I know for a fact. But Adjust is a mobile attribution company, meaning we build SDKs that go into apps and track where users are coming from and what they're doing and how they're monetizing in the app. So those of you who are currently staring in their phone, there's a very high chance that you're staring into an app that we're tracking. Statistically speaking, we're on around 10 apps of each of your phones, and we see around 600 million users every day. But let's go back a little bit. So how did it all start? That's actually a pretty good question. So in 2012, Robert and I, and it was really just us two, started setting up the architecture for our brand new attribution company. And out of sheer habit, because we've done it before and we had really no experience with the cloud, we used bare metal servers at Hetzner. And we started setting up the service on these services because they brought us a couple of advantages. So at the end of 2012, so that's the year that we started, that's the setup that we had. 13 machines, just one rack, nothing too crazy, right? Hetzner provided us with the advantage that a machine costs around something like 50 euros, the rack was 160 euros, and you can terminate services within a month, and you can relatively quickly add servers. Of course, most of the system was vastly over-provisioned because we, like the little amplitudes in the 1 or 2 users we actually had back then, the daytime usage of the app made for pretty big spikes. So the typical utilization of the system was somewhere around 20 or 30%. So what if we would have actually used the cloud instead of using bare metal servers? And Robert did a lot of math and spent days on the AWS calculator to actually answer this question. So this is the question answered with the current AWS pricing. Like, we were not able to reconstruct the 2012 pricing. But what you're seeing, actually, the blue line over there, that is the service cost from Hetzner. And the other lines are different kind of models with AWS. One of the important things that you probably know is that you can prepay with AWS for 1, 2, or 3 years and get a lower monthly pricing, right? So the highest graph that you're seeing is just the Amazon reserved instances using this exact same hardware as we have used on Hetzner. But as I said, it was vastly over-provisioned. In the cloud, you would probably not over-provision your system by a factor of 4 or 5 because you can quickly spawn more instances and you don't have to wait days or maybe even a week to spawn a new server. So the actual cost for the cloud in this case would have been much lower, right? If we're looking the orange graph is a model with a very, very kind of conservative approach of how little you could have actually bought in terms of utilization and not over-provision so much. Factually, you probably would have been able to do it for half. And of course, most importantly, if you ask anybody from AWS or Azure or Google Compute Engine, if you're a startup, they're typically giving you 100K, 200K, I heard anything up to $250,000 in starter packages or startup help. So for the first year, maybe even first 2 years, we wouldn't have to pay a single cent in the cloud. So why the hell did we actually use bare metal? Like, are we stupid? It's a fair enough question. So fast forward to today. We've gotten 1 or 2 more servers. As you may see, the system setup that we're running now is a bit more complicated than before. So it's 240 machines, 8,500 CPUs. One of the crucial parts of our infrastructure is actually fully switched 80 gig network internally between our racks and individual servers that are actually hooked up with 40 gig lines. It's quite important for some of the clustering that we're doing, getting into that later. But as you can see, that's at least halfway serious setup. The problem with that is now that has a slightly different pricing in the cloud. But a fair enough question is, what happened between 2012 and 2017? I guess that was every entrepreneur's dream. It was certainly our worst nightmare at some points, because in September 2012, we had around 40 requests per hour. That was kind of handleable. At the end of 2012, we had 1 request per second, or as many people say, 60 requests per minute. Now, in 2013, we started to see the first time hitting 1,000 requests per second. And we set out to build what we called our 100K project. So we designed an architecture that we were, halfway convinced about, that it would be able to handle 100,000 requests per second. Today, because we figured, that should be like the upper limit of what we could possibly see as a company. Today, on a normal day, we never fall below 100,000 requests per second, and we have peaks of around 150,000 requests per second incoming to our system, and that is just the incoming request. It just is basically a big data pipe for the mobile ecosystem where data comes in and data comes out. So we're also sending out roughly the same amount of requests at the same time. So that is actually the economic side of this whole thing. So we went from a dinky 3-people company to actually it's 160 employees by now. We have 14 offices all across the world. We're the biggest attribution SDK. So in the top 200 apps, most of those apps actually use us for attribution. And so that huge commercial success is what actually drove this massive infrastructure growth. So at some point, because we regularly get approached by cloud providers coming to us and say, hey, if you switch to us, we're going to give you $1 million in rebate, and we're going to make you the best price, and we're going to give you a great deal, whatever. So the question is, what would we actually pay in the cloud? Now, we already saw that a straight-up hardware comparison doesn't really make much sense. So Robert actually did sit down and take the AWS calculator and calculated individual parts of our infrastructure. And so these parts are actually comparable because you can roughly see what kind of hardware and kind of storage, CPU requirements you have. But our first example here, which is our Aerospike cluster, starts already having a couple of problems. First of all, at least we're pretty much free to cram as much RAM into a server as physically possible and currently technically available. Of course, we always make a break between like commercially interesting, but we currently stack 768 gigs per Aerospike node. Amazon only offers you 448, at least in the official pricing list. I know in the documentation there's instances with more, but we didn't find that for sake of comparison. So you definitely need a couple of more machines, but that is not really where the problem lies. Who of you knows how multicast networking works in the cloud? Google, Amazon, Google Compute Engine, and Azure. Good. It's a trick question because it doesn't. There's no multicasting in these networks because virtualized networks don't do multicasting. It's one of the little pitfalls. So if you want to do multicasting, you actually have to do a point-to-point mesh network between all the individual nodes. Now that's an exponential problem the more nodes you have. Suddenly having 40 nodes is a much bigger problem than having 20 nodes because your network load increases exponentially with the number of nodes. But that's solvable, right? There's a very, very fun guide for all of you who thought that Amazon doesn't make great April Fool's jokes. Definitely read the documentation on how to set up multicast networking. It involves a Ruby daemon that routes all of your packages. So the problem, though, is that's not the worst part. Because we talked to Aerospike because we were curious. What happens if we put our cluster onto AWS? I mean, the short answer was seriously don't. But there's, for example, network latencies. I don't know who of you has some experience with the beautiful AWS network and its spiky little latencies, meaning that the 99th percentile of the network is, well, not that reliable. So you have extreme spikes in network latency from time to time. Turns out clustered software like Aerospike and pretty much any other big clustering software really doesn't like that kind of thing because it tells them that one of the nodes is down. So you have to seriously raise the timeout limits for your nodes. You have to really massage the configuration not to constantly go into split brain mode because it thinks all of the nodes are gone. Now you think, okay, that sounds pretty bad. Still not the worst part. The worst part actually, specifically for this, is machine pauses, right? It is not uncommon that the virtual machine that you rented gets transferred from one physical machine to another. As magical as that sounds, in the real world, that does include a pause. The machine is paused, transferred, and turned on again. That, of course, is the worst thing that could happen to your cluster node because it doesn't react in that time, meaning the rest of the cluster will probably soon just die and will start a full rebuild. Now, the same thing happens to another cluster node while the rebuild is happening and you're in for some real fun time. So, but let's put this all aside and just look what this would actually cost. So, Robert was very nice when comparing the prices with AWS. All of these payments are the 3-year full prepaid contract. So this is the maximum prepay amount to get the most or to get the lowest effective price per month possible. Right? I know you'll probably get some kind of 10% friend rebate or whatever, but this is pretty much you pay $1.2 million right now, and for the rest of the next 3 years you pay $278,000. Of course, it kind of removes the effective scaling down thing from the cloud, but it's the only way to get the pricing. If we would compare on-demand pricing, the on-demand pricing is 2 or 3 times higher. So, we also use Elasticsearch at a interesting enough scale, I would say. So, to give you an idea, our Elasticsearch cluster currently stores, and I have to look at my systems to correct me, 480 billion documents. That's what we roughly keep in. So we store 15 billion documents a day. We have 57 machines that are currently taking care of that. There's a couple of petabyte of disk in there. And it's definitely one of the more interesting bits of our architecture because it uses a lot of bandwidth. So technically speaking, you couldn't run our cluster in the cloud because you can't get the networking bandwidth necessary to make this feasible. Because you can get 10 gig network, you can't get 40 or 80 gig networks. But there is, of course, you could say, well, you know, you could save some time by using managed Elasticsearch because Amazon offers managed Elasticsearch, right? The funny thing is that it has a tiny little asterisk saying it is limited to 150 terabyte space. For us, that would mean we'd have to spawn a new cluster every day and then try to connect them together when we want to ask it something. So that really removes the easy-to-use part for us. Cost of that, so we're going to stay with the lower costs, from like 180,000. One of the examples where it actually turns out where the cloud would be slightly cheaper, if you just look at the prices, our Redis cluster, we also have a tiny little Redis cluster where we store our configurations and stuff like that in. Where if we look at the effective cost, what we physically pay for that, at least for right now, is a little bit more. But again, here you have some of the problems that cluster software doesn't really like virtualized network, doesn't really like machine pauses, and doesn't like most of the things that you actually get for free in the cloud. So one of the other things that we do, which is kind of CPU intensive, is our SSL offloading. So all of these little signals coming from the SDK, of course, hit our server, SSL secured. We don't want to send your data around in clear text. So we have 8 SSL offloaders, though that sounds kind of harmless. These are like Dell 930s packed with CPUs. I think they have over 100 CPUs, each of them. And they are running at a pretty high load to do more than 150,000 SSL terminations per second. At Amazon, we're not really sure if that would really work because there was no one who would be able to answer the question if that is enough bandwidth and CPU to actually do what we're doing, because we're also using quite a specific setup that involves OpenSSL using the specific Intel IS registers to speed up the whole thing, which gives us around a performance boost of 4 to 5. Otherwise, we'd have to use much more servers. So let's say that's another 150,000 per month. Now one of our piece de resistance and the real expensive machines, we're running multiple Postgres clusters, one for the raw data, one for the aggregated data. This is 20 machines is the raw data, 16 machines is the aggregated data. Those machines really cost money also, like on our side already. Same problem is all of the managed Postgres services have way too low limitations in terms of how much space you can cram into one. One of our raw data nodes has 14 terabyte of disk in it. That's something you simply cannot get on Amazon, right, or Google or Azure. So that's roughly 400K per month. So the things that I just mentioned to you is roughly $1 million per month. And that does not include large parts of our infrastructure, right? All the monitoring servers, the front end, testing, integration. There's many, many more machines that are not on here. Also, what's not on here is we're currently running a second data center. I'm getting to that later, but in the cost that I'm going to show you in a second, it does include already a second data center that we're running, none of which machines is actually included in the little comparison here, right? We just assume we'd magically be able to spawn these Amazon machines across multiple availability zones and figure out how to do proper failover should one zone actually fail. So this comparison is really trying to be as nice as possible for cloud services. And so one of the reasons that actually Just is, at this point in time, a profitable company, and quite profitable actually, is we don't pay $1 million. So I don't know if you guys want to guess what we're actually paying for our hardware, but I'm really going to show you the actual graph, what our bare metal servers really cost. So this is a state secret, of course, but we currently pay around a quarter of that. And again, that involves around 40,000 euros of servers that are not in this comparison, that are currently running at a different data center, because as we speak, we're rolling out our services across multiple data centers to get a high availability setup going. Meaning the effective more cost for the cloud for us is somewhere between the factor 5 and 6. And as you can see, this is not some chump change. That is like serious money we're talking, right? That would be multiple $1 million or euros, if you like, every year that we'd have to pay more for Amazon. And that is basically the idiot tax that you pay for starting out on it, right? No one has anything to give away for free. If someone gives you $250,000 for free and you think that's for free, I got bad news for you. Because as you see, the rebate that they gave you at the beginning would barely keep you afloat for a week now, right? So anytime you actually get to a scale that you always dreamed about with your company, that is where they get you. That's where you really pay them, right? At the beginning, where you save all of that money, and it's such a great investment, and it's so much more complicated to actually hire sysops. I can tell you from the $250,000 I save every single month, you can get some good sysops, right? I mean, we split the sum evenly across the 5 people we have, so it's fair. No, but you see my point, right? It definitely makes sense to invest in better people than actually to think that you can just automatically scale out no matter how big you're going to get, because at some point this is going to come back and haunt you. And this is the difference between being a profitable company and having nice casual conversations with investors, or being the sucker that has to beg for more money and more money and more money and raise a Series D, Series E, and whatever, because you can't get your hardware and operation costs under control. So now you're saying, well, I could take the entire system and not use physical hardware running my own kind of services. I could use the magical managed services that, for example, a Google Compute Engine offers, right? I just don't spawn my own machines. I only use BigQuery and all these kind of things. Well, that has a couple of problems. First of all, we're a startup, right? Every startup that takes up investment is doomed to be sold at some point. That's just, that's the way it works. The problem is, what kind of intellectual property did you develop if you just shoestring together a couple of Google services? Pretty much everybody can do that, right? There's no big challenge in that one. So that definitely reduces the kind of value of the intellectual property you you made. And you say, well, I don't care about that. I say, fine. You have a slightly awkward lock-in situation going on because you're not going anywhere. You're not going anywhere if you have your machine spawned up in AWS because you're tied into all of these services managing that already. But if you're using managed services, you're using a proprietary API that is only available on a single provider. So where the hell are you going to go? And basically, that puts you pretty much at their whim. Either they could change the pricing to your disadvantage, start charging on something that they just came up with, or they could shut down services, and they would simply shut down you. The other thing, of course, is developing on these services now no longer is how can I write the fastest piece of software that I can. It becomes how can I write the cheapest piece of software. Because all of those managed services don't actually charge you on things that physically really cost money on the machine that it's running. They charge you on arbitrary things that you can barely avoid, but that you have to do, like numbers of writes or something like transfer volume. Transfer volume doesn't cost anything, right? They pay for bandwidth. Bandwidth, on the other hand, compared to transfer volume, for example, if you look at Amazon's pricing per gigabyte, like transferring data in and out, if you look at what bandwidth you would usually need, that's 1,000 times more expensive than just buying your own line. That's how they get you, right? And this goes on. This on the managed services, this is really the shit that makes you crazy. If you look at what a single BigQuery question can cost, you can easily spend $5,000 in a second on BigQuery, simply asking it a single question, and bam, you're 5K in the hole. And now imagine you have a data scientist who really doesn't know that. Before your company quota is used up and your whole services come to a grinding halt, maybe you get an email. But the point is that you really are dependent on someone who can arbitrarily price what you're doing, and what you build is really not that unique anymore. So now you say, well, but the cloud is so high available, right? And I'm saying, well, I hope your S3 storage is back online by now. Because that was something that really annoyed us, because we have many clients that we have to upload data to. And we can see how freaking often Amazon, for example, is down. Like many clients, like you all go, yeah, well, there's multiple availability zones. So if you spread this out properly, nothing bad happens. So who really does that? Because I know our clients really don't. So every day, one or two of those clients just disappear because their load balancer has fallen over, or one of the many things, like if you have 4 services kind of depending on each other, Amazon only guarantees you the 99.9 uptime on every one of them. If you need all 4 of them, you don't have 99.9, you have 99.5% uptime guaranteed. It's a fun little trick. And it doesn't really help you if you get 20% of your money back if S3 was down for a couple of days, right? So anyhow, you could still argue proper setup, multiple availability zones. The good news is if you find a hoster that is big enough, like, for example, LeaseWeb, that has multiple data centers across the world, they're most likely also willing to give you physical connections between those. One of the examples is we have a data center in Amsterdam currently being set up where we want to split out our complete tracking load, and at the end of the year, we're hoping that we can also start a 3rd data center in California to be able to have a failover should one of the data centers become unavailable. And I mean, so far, knock on wood, the Frankfurt data center hasn't gone offline at all, so we hadn't seen any similar downtimes to what you've experienced on AWS, for example. But it is possible to get the same kind of thing. Of course, you have to plan ahead, right? You have to have a better idea of what you want to do. It is not as easy, and you have to get a little bit more down into the details of how stuff actually works under the hood. But at the end of the day, if you want to run a high-performance services in the cloud, you will have to do the same thing eventually, right? And one of the very cool things, for example, we can use as a little company is called DataPath, and what they allow you is to do TCP anycasting, meaning we have a single IP address worldwide, and we can route where this IP address actually physically points where you are, depending on your location. Right, so we can say all American users are routed to the California data centers, I don't know, Mid-Eastern users go to Amsterdam, the rest of the world goes to Frankfurt. And that works very, very quickly. So the failover on this one is in the realms of something like 5 seconds or so. So should one of the data centers decide not to be available any longer, we can simply reroute the entire traffic within a couple of seconds. So no complicated DNS routing with TTLs or anything. We can simply point our traffic, depending on in what autonomous zones you're in, independently. So the scaling factor, last but not least, where you go, well, but how do you use scale? How is it even possible? Because that's the main argument I typically hear when people say, well, I want to use the cloud because scaling is possible and scaling on hardware isn't possible. Well, I'd say, well, we kind of shown that it is reasonably possible to scale. As you've seen, last 5 years, we added 1 or 2 servers and we're still here. So it's possible. But of course, you need a strong sub team. You need actual know-how within your company, and reckon that never actually hurts. And you need a plan, right? Another thing is, of course, it helps having a strong partner that is able to reduce delivery times on certain hardware items. So where you can say, look, guys, I'm really a bit in a bind here. I need hardware quick. And so far, it always worked that we were able to at least get some temporary servers that could fulfill our needs on a very, very short note, sometimes hours, worst case days, while we're waiting for the actual delivery of the big machines that we're ordering. And that always helped us to stay ahead of the game. Of course, it requires a little bit more planning than just, in the morning go, oh, I need more servers today. But most of the time, the bigger your company grows, the less over-provisioning you have to do. Like our current over-provisioning is, let's say, somewhere around 10, maybe 20%, because there's not enough people in the world for us anymore to produce another ×2 spike. That's just, there isn't enough phones so far. And so that allows us to go much closer to the kind of efficiency of the physical hardware that we're actually operating at. So, quick sum up. I've shown you that it is actually possible to scale a company at quite a brisk pace on physical hardware, and that the cloud services make sense if you're not really running all that much hardware, or you only plan to run this for 2 years and then just want to ditch. But if your plan is to scale a company to your wildest fantasies in terms of size, then it may make sense to actually sit down, look at the cost of hardware, because this could be the difference for you to be a profitable company, or to go broke at some point, or have to beg money from your investors giving away shares from your company. And so getting a capable SysOps team should definitely be one of your very first to-dos. I was very lucky to have Robert join me very early on. Sad that he isn't here today, that you could have seen, but he's quite a capable person who actually set up all of the system and came up with all of these brilliant things, allowing me to just run around and give talks nowadays. But yeah, I think the moral of the story is that the cloud looks very cool, specifically at the beginning. And I understand everybody that is kind of falling to the temptation to go, look, I don't want to deal with all the complicated hustle, and I don't really want to spend time on this now. I'm going to fix this later. I've never seen anyone fix this later, right? People always say, I'm going to fix this later. 5 years in, you sit there, you get a bill of $500,000 a month, and you're not fixing that. The only people I ever seen trying to fix that was the new guy that got hired after the old guy got fired. So, definitely thank you for your time. I hope I could give it almost as well as Robert would have given it. And yeah, thanks.
Any questions for Paul? Yeah.
So for the Amazon pricing, it looks like you used all of the public pricing and not what a salesperson would actually sell you. So if you're spending upwards of hundreds to thousands a month on Amazon, they typically give you pretty good discounts. I've heard of 30 to 50 or more %.
Well, we'd be looking at an 80% rebate.
Yep. No, I'm just saying for fair comparison, when you actually start getting into scale on cloud providers, they do sell you significantly reduced bulk discounts.
Sure, but again, the thing is, this comparison is let's say, awkwardly fair.
Yeah.
We would not be willing to prepay for 3 years, right? Because the prepay...
That's not even prepay. That's actually just normal. You can get an off-the-top discount with cloud providers.
No. Without kind of divulging too much NDA data, I did talk to Amazon, right? Yep. And we did look at the rebates, and we only asked them to configure a single part of our infrastructure. And it was still 3 times as expensive.
Yep.
Right?
No,
So,
I totally believe it, but just for fair comparison.
no, of course. I mean, again, Robert tried with the public pricing to be as fair as possible, doing the 3-year prepaid. I reckon most companies wouldn't be willing because that prepaid sum was hefty. That was like 8 million cash down right now, right? I don't think anybody would do that.
Yep. Thank you.